Picture a sprawling, high-tech metropolis at night. Heavy rain is pouring down, and you've got these massive, towering skyscrapers reaching up into the dark clouds. Vibrant neon signs are reflecting in the puddles on the street below, while flying vehicles just constantly dart between the buildings in this glowing, non-stop stream of motion. It's a hyper-connected network of data, shadows, and, well, vulnerabilities. This moody cyberpunk reality is actually the perfect metaphor for what the modern internet looks like just beneath the surface. Welcome to This Explainer. Today, we're bringing some serious energy to a deep dive into the reality of web security. And we're going to peel back that neon facade to look at how hacks actually happen. Okay, let's dive into this by looking at how our digital city was built in the first place. In the early days, what we call the static web, or Web 1.0, the internet was, frankly, basically a digital brochure. It was a one-way street where servers just handed you static documents. If a hacker managed to break in, the worst they could usually do was deface a public page. Big deal, right? But then we evolved to the dynamic web, or Web 2.0. Suddenly, those quiet streets became massive two-way highways. Today, applications are processing highly sensitive private data, from your bank accounts right down to your personal text messages. And here is the fundamental trade-off we have to accept. More functionality absolutely always means more vulnerabilities. Now, our guide for this journey into the digital shadows is the definitive, elite cybersecurity manual, the Web Application Hacker's Handbook, 2nd edition. It was written by industry heavyweights David Studdard and Marcus Pinto. And let me tell you, this isn't just some dry academic textbook. It is a literal field manual for understanding exactly how attackers view and systematically dismantle modern web architecture. To really wrap our heads around this, we're structuring this explainer directly through the methodology and journey of an actual hacker. We'll be looking at 1. The shifting security perimeter, 2. The illusion of security, 3. Core defense mechanisms, 4. Attacking the data store, 5. Targeting users with XSE, and finally, 6. The hacker toolkit. Let's get moving. Section 1. The shifting security perimeter, from the network firewall to the application. So I like to use what I call the castle to town square analogy here to explain this shift. Think about it. In the past, network security was exactly like a medieval castle. You built a massive firewall, your castle wall, and you just kept all the bad guys outside. If they couldn't breach the wall, you were safe. Simple, right? Well, modern web apps aren't castles anymore. They are bustling town squares. You literally have to invite the entire general public inside to interact, buy things, and exchange information. So the perimeter is no longer the firewall because all that traffic is passing right through the front gates by design. The new perimeter is the web application itself. Moving on to Section 2, the illusion of security, shattering the myth. Okay, get ready for this, because the sheer scale of the problem we're facing is just staggering. According to extensive tests run by the authors of our handbook, a whopping 94% of tested applications contain cross-site scripting, or XSS, flaws. I mean, think about that. In over 9 out of 10 applications, an attacker could potentially execute malicious scripts directly inside your browser. And you know, it doesn't stop there. 71% of those tested applications suffer from broken access controls. This basically means that a standard, everyday user can often just tweak a parameter or mess with a URL and suddenly, bam, they gain unauthorized access to another user's private data or even sensitive administrative functions. Finally, 62% have broken authentication. We're talking about things like allowing brute force attacks, using predictable session tokens, or having easily bypassed logins. All of these statistics prove one terrifying point. SSL certificates, you know, that little comforting padlock icon in your browser that says your connection is secure? Yeah, it does absolutely nothing to stop application layer attacks. It literally just means your data is safely encrypted, right up until it travels to a totally broken, vulnerable application. So the crucial point we have to understand is this. Developers must treat all user input as potentially malicious. Why? Well, because the client side, your web browser, is completely outside the application's control. A hacker doesn't have to play nice and use a normal browser like you or me. They can intercept, pause, and rewrite every single piece of data sent to the server. If the application on the other end blindly trusts that input, the walls come tumbling down. Section 3. Core defense mechanisms, the Holy Trinity. To fight back, web applications rely on what we can call the holy trinity of defense. First, authentication, to prove who you are. Second, session management, to track your state after you successfully log in, and third, access control, to determine what you are actually allowed to do once you're inside. But remember, this is a tightly interrelated chain. Hackers constantly poke at all three, just looking for a single defect. A failure in just one of these components gives an attacker unrestricted access and unravels the entire security model of the site. Section 4. Attacking the data store, behind the scenes. All right, let's talk about one of the most notorious weapons in the hacker's arsenal, SQL injection, or SQLI. This happens when an attacker submits specially crafted input that basically tricks the application into interfering with its own backend database. So instead of just searching for a username like a normal person, the attacker injects malicious commands right into the database's native language. And the outcomes of a successful SQL injection, they are absolutely devastating. A single line of crafted input can allow a hacker to completely bypass login screens. They can extract arbitrary sensitive data, meaning they could literally just download the entire customer database in one go. They can subvert the application's logic to, say, change prices on an e-commerce site or elevate their own privileges. In the worst-case scenarios, they can even execute commands directly on the database server's underlying operating system. It's wild. One tiny flaw, total compromise. Section 5. Targeting users with XSS, the Trojan horse. Enter cross-site scripting, or XSS for short. You can think of XSS as the ultimate Trojan horse. You see, instead of breaking into the server to steal data, the hacker uses a flaw in the application to deliver a malicious script directly to the browsers of trusted users. The application unwittingly becomes the delivery mechanism itself, handing the attack straight to its own unsuspecting customers. Now, this malicious delivery basically comes in three main flavors. First, there's reflected XSS, where the payload is hidden inside a crafted link that the victim is tricked into clicking. Second is stored XSS. This is where the malicious script is permanently saved on the server, like hidden in a blog comment section, attacking literally anyone who views that page. And third, DOM-based XSS. This is a really tricky variant where the malicious payload is executed entirely on the client side, without the server ever even seeing the attacker's script. You know, there's this dangerous myth out there that XSS is just kind of lame virtual defacement, like just popping up annoying little alert boxes as a prank. Actually, scratch that. It is entirely false. A skilled attacker uses XSS to inject Trojan login forms that seamlessly steal your passwords right out from under you, or to silently read your cookies and achieve complete session hijacking. With a solid XSS exploit, the hacker literally becomes you. Section 6, the Hacker Toolkit, Automating the Assault. And this brilliantly illustrates how the reality of modern hacking isn't just some lone figure in a dark room typing furiously on a keyboard. Manual hacking eventually gives way to automated toolkits. Just like that cyberpunk digital city we talked about at the beginning, with data streams flying in all directions, hackers use automated, hyper-efficient tools to manipulate those streams, bypass client-side controls, and map out an application's attack surface far faster than a human ever could. So let's break down the core arsenal in this toolkit. First up, the intercepting proxy. This is absolutely the most vital tool. It sits right between the hacker's browser and the target server, allowing them to freeze, inspect, and modify every single request before it hits the network, completely bypassing any client-side rules. Next, web spiders. These tools automate the entire mapping process, rapidly crawling through every directory and hidden file to find the application's true boundaries. And finally, fuzzers. These are automated engines that just rapidly fire hundreds of crafted attack strings into every parameter they can find, waiting for an error message or an anomaly that signals, you guessed it, a vulnerability. We've journeyed from the simple, static web all the way to a dynamic, hyper-connected digital metropolis, where the perimeter has shifted. That little padlock icon means almost nothing, and literally every input is a potential weapon. So I want to leave you with this to consider. The next time you log into your bank, your email, or your company portal, is your data truly secure, or is it just resting safely behind a comforting illusion? Thank you so much for joining me on this explainer, and definitely keep questioning the security of the digital world around you.